At first glance, this looks like a problem you would see on the very first day of a calculus class. We are asked to find the derivative of the function x to the power of x. It seems simple, almost too simple, but this is exactly where the trap is set. Most students look at this and immediately apply the most common rule in calculus, only to get the answer completely wrong. Step 1. The common mistake. When students see an exponent, they instinctively reach for the power rule. The power rule states that to find a derivative, you bring the exponent down to the front and subtract 1 from the original power. Following this logic, many would say the answer is x times x to the power of x minus 1. While this looks correct, it is a mathematical hallucination. The power rule only works when the exponent is a constant number, like 2 or 3. It does not work when the exponent is a variable, like x. Step 2. A different perspective. To solve this correctly, we need a way to move that x out of the exponent position. We can do this by using a powerful tool called logarithmic differentiation. Let us start by setting our function equal to y, so we have y equals x to the power of x. To break the exponent free, we take the natural log of both sides of the equation. This gives us the natural log of y equals the natural log of x to the power of x. Step 3. Using the log property. Now we can apply one of the most useful rules in algebra. The property of logarithms allows us to take an exponent and move it to the front as a multiplier. By pulling that x down, our equation transforms into the natural log of y equals x times the natural log of x. Now the function is in a form where we can actually use our calculus rules. Step 4. Differentiating both sides. Now we take the derivative of both sides with respect to x. On the left side, the derivative of the natural log of y is 1 over y multiplied by the derivative of y. On the right side, we have x times the natural log of x, which requires the product rule. The product rule tells us to take the derivative of the first part, which is 1, and multiply it by the second part, the natural log of x. Then we add the first part, x, multiplied by the derivative of the second part, which is 1 over x. Step 5. Simplifying the right side. Let us clean up that expression. 1 times the natural log of x is just the natural log of x, and x times 1 over x simplifies perfectly to 1. So our equation now looks like this. 1 over y times the derivative of y equals the natural log of x plus 1. We are almost there, but we need to solve for the derivative of y alone. Step 6. The final substitution. To get the derivative of y by itself, we multiply both sides of the equation by y. This gives us the derivative of y equals y times the quantity, the natural log of x, plus 1. For our very last step, remember that at the beginning, we defined y as x to the power of x. We can now substitute that back into our equation to get the final result. The final answer. The derivative of x to the power of x is x to the power of x times the quantity, the natural log of x, plus 1. This problem is a perfect example of why you should never jump to conclusions in math. By slowing down and using logarithms, we uncovered the true solution that most people miss. If you found this explanation helpful, don't forget to like and subscribe for more deep dives into the logic of math. Until next time, keep